Question number 36. When light of wavelength lambda is incident on a metal surface, the stopping potential is found to be V0. When the light of wavelength n lambda is incident on the same metal surface, the stopping potential is found to be V0 upon n plus 1. The threshold wavelength of the metal is. Now, we have to establish the relation between threshold wavelength and this wavelength lambda, incident wavelength lambda. We know the very famous relation. E times stopping potential will be given by energy of incident photon hc by lambda minus of work function. So from here we will get V0 as hc by lambda minus work function can be written like hc by lambda naught whole divided by E. This is equation number 1, suppose. Now, according to question, the incident of wavelength light is n lambda. So, as a result, the stopping potential becomes V0 upon n plus 1. Putting the values, now stopping potential is V0 upon n plus 1 equals 1 by E. Incident light has the wavelength n lambda, so hc by n lambda will be energy associated with it minus work function is the property of metal surface. So if metal surface is same, so work function will also be the same, lambda naught. Equation number 2. Now we have got two equations, and after solving these two equations we get after solving 1 and 2 we will get the value, that is lambda naught equals n square times lambda. So this is our final expression, and if we find the option we will see third option is absolutely correct. This was question number 36. Now let us proceed to the next question, that is question number 37. The product of angular speed and tangential speed of the electron in nth orbit of hydrogen atom is. Okay, now we have to establish the relation between angular speed and tangential speed of electron of the nth orbit hydrogen atom in terms of n. We know very well that the radius of nth orbit Rn is given by n square epsilon naught h square upon pi times me square. Therefore we can say that R is related to n square, something like this, because rest of the expressions or rest of the quantities are constant. Similarly, we know that speed v of nth orbit is given by e square divided by n times 2 epsilon naught h. Now if you see the expressions you will find that v is inversely proportional to n. Now if we multiply the linear speed or tangential speed with the angular speed, it will give you what? Centripetal acceleration, v equals to r omega. So ultimately omega square r, or you can write it like v square by r. Now v is proportional to 1 by n, so v square is proportional to 1 by n square. First thing. Now r is proportional to n square, so 1 by r will be proportional to 1 by n square. So as a result we got v into omega proportional to 1 by n to the power 4. This is our final expression, and if we go through the options we will find that third option is absolutely matching, inversely proportional to n to the power 4. So this was question number 37. Now we will proceed to question number 38. Here is question number 38. At a place, horizontal and vertical components of Earth magnetic field are as follows. Horizontal component is 1 Gauss 5 degree east of Earth. Vertical component is 1 Gauss vertically upward. Now we have to calculate the inclination and declination respectively. First of all, the horizontal component is 1 Gauss 5 degree east of north. So this is your angle of declination. So we got the declination directly from here, that is 45 degree east. Now for the angle of inclination, we have a very famous relation, that is tan of angle of inclination, that is tan delta, where delta is angle of inclination, is given by vertical component of earth magnetic field divided by horizontal component, and both are equal to 1 Gauss, so 1 by 1 exactly equal to 1. We got the value of delta as 45 degree. So angle of declination is 45 degree. Now after looking at our expressions, finally if we go through the options, we will find that option number 3 is absolutely matching, absolutely correct. So we will go with option number 3. Now let us proceed to the next question, that is question number 39. Question number 39. If charge Q1 and Q2 lies inside and outside respectively of a closed surface S, let E be the electric field at any point on S and phi be the electric flux over S, then select the incorrect option. We have to choose the incorrect option. Now S can be any random surface. So suppose this is a random surface. We have assumed a charge Q1 is inside the surface, on the other hand charge Q2 is outside the surface. Now let us proceed to the options. Option number 1, if Q1 is 0, Q2 is non-zero, then electric field E is equal to 0 but phi will be non-zero. See, if Q1 we take 0, then according to Gauss theorem, the total flux passing through a closed surface S will be given by the total charge enclosed by the surface divided by epsilon naught. Now if Q1 will be 0, then the net charge will be 0, and therefore the flux must also be 0. It means we have to pick the incorrect option. So option 1 we can pick here because it is incorrect. Now let us proceed for option number 2. If Q1 changes, both electric field and phi will change. It is very much obvious, if Q1 will change, then field will also change, and if the field will change, then flux will also change. So this is correct, but we have to pick incorrect option. Option number 3, if Q2 changes, E will change, but phi will not change. Phi, flux bounded with the closed surface, is associated only with the charge enclosed by the surface, that is Q1. So if you change Q2, it will not affect the flux bounded with surface capital S. So option number 3 is also correct, but we have to pick the incorrect option. If Q1 is non-zero, Q2 is non-zero, then flux also be non-zero. Definitely if Q1 is non-zero, then certainly some flux will be bounded with the closed surface. So that is why it will be non-zero. So fourth option is also correct, but we have to pick the incorrect option. So we will proceed with option number 1, which says that if Q1 is 0 and Q2 is non-zero, then E will be 0 but phi will be non-zero, which is not possible. So we will proceed with option number 1. Now let us proceed to the next question, that is question number 40. A plano-convex lens exactly fits into a plane concave lens as shown in figure. If the lenses are made of different materials of refractive index mu1 and mu2 and r is the radius of curvature of the curved surface of the lens, then the focal length of combination will be what? If we are having two lenses, then the focal length of combination is given by 1 by f equals 1 by focal length of first one plus 1 by focal length of second one. Now let us calculate their individual focal lengths. We know that the focal length of any lens will be given by mu minus 1 inside the bracket 1 by r1 minus of 1 by r2. Now for lens 1, let the focal length is f1, so 1 by f1 equals refractive index with surrounding is mu1, so mu1 minus 1 by first surface is plane. The radius of curvature for plane is infinity minus of 1 by minus of R2, that is minus R. So ultimately this gives you 1 by F1 equals mu1 minus 1 by R. Similarly, 1 by F2 will be given by the refractive index with respect to surrounding is mu2 for second lens. So mu2 minus 1 by first is surface is curved, on the other hand second curved surface is plane. We know that the radius of curvature for plane is infinity, so we will get minus of R as a result. Now this is equation number 1, this is equation number 2. Adding 1 and 2, we will get the focal length of combination as mu1 minus of mu2 whole divided by R. Therefore, the focal length of the combination will be given by R divided by mu1 minus mu2. So this is our final result. This is the focal length of combination shown in diagram. Now we can see that option number 2 is absolutely correct.